matrix multiplication. The first type of multiplication we want to consider here is what we call multiplication by a scalar. Now, a scalar here simply means a number. Any number is called a scalar. So, for instance, here we have a matrix. Let's consider a general 2 by 2 square matrix with entries A11, A12, A21, and A22. So, if we take a scalar, say alpha, and we are asked to compute or so find alpha A. So this means we should multiply the matrix A by the number or by the scalar alpha. So what would this mean? This would mean alpha times A simply means alpha times the matrix A11, A12, A21, and A22. So how do we now perform such multiplication? We multiply every entry or each entry of matrix A by the scalar alpha. So that becomes alpha times A11 is alpha A11, alpha times A12 is alpha A12, alpha times A21, alpha A21, and finally alpha times A22 is alpha A22. So when we do this, we now say that we have multiplied this matrix A by a scalar alpha. Now let us take a more concrete example to see what is happening here. So let matrix A be the matrix with the entries 2, minus 3, 4, 5, 6, and 7. Now this matrix is a 1, 2, is a 2 by 3 matrix. That's the order of the matrix. Matrix B has the entries 4, 0, 3, minus 8, 2, and 9. This also is a 2 by 3 matrix. So we're asked to find 2A minus 3B. Now 2A here is multiplying this matrix A by a scalar 2. 3B here also means multiplying matrix B by a scalar 3. Then we subtract. Okay. So let us compute 2A first, then 3B, then we subtract. So 2A simply means to multiply, to put 2 and multiply 2 by the matrix A, 2, negative 3, 4, 5, 6, and 7. Like we did before, to multiply a matrix by a scalar simply means to multiply each entry of the matrix by the scalar. So this will simply mean, so 2 times 2, so then let me just write it out. So 2, I'm going to times 2, then the second entry here is 2 times negative 3, 2 times 4, 2 times 5, 2 times 6, then 2 times 7. That's what we mean by multiplying the matrix A by the scalar 2. So if we do this, we'll get this is equal to 2 times 2 is 4, 2 times negative 3 is minus 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12, 2 times 7 is 14, and that is 2A. So I've multiplied the matrix A rather, by the scalar 2, hence multiplication of a matrix by a scalar. So on the other hand, we'll check what 3B is and then find this difference. So 3B also means multiplying the matrix B by 3. So matrix B is 4, 0, 3, minus 8, 2, and 9. So multiply out. So like we did before, this simply means multiplying each entry of the matrix by the scalar 3. So I'll do it directly now. 3 times 4 is 12. I hope you understand. 3 times 0 is 0. 3 times 3 is 9. I'm done with the first row. Now second row. 3 times negative 8 is negative 24. 3 times 2 is 6. 3 times 9 is 27. So 3B is equal to 12, 0, 9, negative 24, 6, and 27. So now we have 2A, we have 3B. We want to now find 2A minus 3B. And this simply means to subtract matrix 3B from matrix 2A. Now if you recall from our very first video on matrices, you know that there's a condition that must be checked before we carry out matrix subtraction. And what condition is that? The condition is that the two matrices we are about to subtract or add must be matrices of the same dimension or the same order. For instance, matrix A here is a 2 by 3 matrix. Matrix B here is also a 2 by 3 matrix. Therefore, the two matrices have the same order or are of the same dimension. Hence, we can go ahead to add or subtract the entries. So if matrix A, for instance, was a 3 by 2 matrix, and matrix B was a 2 by 3 matrix, then the dimensions will be different. And so, matrix subtraction cannot be performed. I hope you remember that. Alright, so matrix 2A is what? 2A is this: 4, minus 6, and 8, 10, 12, and 14, minus 3B. 3B is 12, 0, and 9, minus 24, 6, and 27. So how do we perform matrix subtraction? We perform it entry-wise. So this is equal to, so corresponding entries. So the first entry here is 4. So 4 minus, the first entry here is 12. Corresponding entries. Second one is negative 6 minus 0. Third one is 8 minus 9. Corresponding entries. The second row, 10 minus 24. 10 minus 24. Then 12 minus 6. And finally 14 minus 27. So what will that be? That gives us 4 minus 12 is negative 8. Negative 6, negative 0 is negative 6. 8 minus 9 is minus 1. 10 minus 24. Now minus times minus is plus. So 10 plus 24 is 34. 12 minus 6 is 6. And 14 minus 27 is minus 13. So that is 2A minus 3B. Now I want to look at multiplication of a matrix by another matrix. What we did earlier was multiplication of a matrix by a scalar. So the question here is, if we're given two matrices, say matrix A and matrix B, is it possible to multiply matrix A by B, which I'll just use dot? Is it possible? And the question is, the answer of course is yes, it's possible. However, there are certain conditions, or there's a condition that must be met, which I want to state now. What's the condition for matrix multiplication, or multiplying a matrix by another matrix? Now you pay attention now. If matrix A, for instance, I'll give examples later, is say a 2 by 3 matrix, and matrix B on the other hand is let me write it here. Matrix B is a 2 by 3 matrix also. This is matrix B, a 2 by 3 matrix. Now matrix A times matrix B is not possible. I'll tell you why. Now you see that for matrix A has 2 rows and 3 columns, hence 2 by 3. While matrix B has 2 rows and 3 columns, same as matrix A. Even though matrix A and matrix B are of the same, dimension, of the same order, yet we can't multiply A and B. Because for us to multiply matrix A and matrix B, the inner dimensions of matrix A and matrix B must be the same. In other words, matrix A has 3 columns, matrix B must have 3 rows. That's the condition. So the number of rows of the second matrix B must be the same as the number of columns of the first matrix A. Since matrix A has 3 columns and matrix B has 2 rows, not the same as 3 columns of matrix A, matrix multiplication here cannot be performed. Another instance, if matrix A now is say a 3 by 2 matrix and matrix B now is a 2 by 4 matrix. Question now is, can we now perform A times B? The answer now is yes. Because matrix A has an inner dimension of 2. That is, matrix A has 3 rows and 2 columns. and matrix B has 2 rows and 4 columns. So what do we see? That the number of columns of matrix A matches with the number of rows of matrix B. Hence, matrix multiplication A times B can be performed. Now, if A and B can be multiplied, the question now is, the new matrix we are going to obtain, what will be its dimension? Now, if a 3 by 2 matrix is multiplied by a 2 by 4 matrix, okay, then what we're going to get will be a 3 by 4 matrix. So A times B will now be a 3 by 4 matrix. Hope it's clear. Let me take one more illustration. If matrix A, we have matrix A and matrix B. If matrix A is a 4 by 2 by 3 matrix, and matrix B, on the other hand, is a 3 by 1 matrix. So can we perform A times B? The answer once again is yes. We can perform A times B because matrix A has 3 columns, while matrix B has 2 rows, rather 3 rows, I beg your pardon. So the number of columns of matrix A matches with the number of rows of matrix B. Hence, matrix A can be multiplied by matrix B. And if matrix A and matrix B are multiplied, our new matrix is going to have a dimension of 4 by 1. So we're going to have a 4 by 1 matrix. So a 4 by 1 matrix is obtained when a 4 by 3 matrix is multiplied by a 3 by 1 matrix. Now I shall take an example to show you then how this multiplication is performed. We shall begin with a simple 2 by 2 matrix. So let A be a matrix with entries 2, 4, 3 and negative 2, and B a matrix with entries 3, 0, minus 5, 4, minus 3 and 7. We want to find the first one A times B, second one B times A. So here A comes first, while in the second part B comes first. So at the end we shall see if AB and BA will be the same. Of course, before we even proceed, to multiplying these matrices, we must first check if multiplication is possible. You should remember. So let us see. Matrix A is what dimension? Is 2. This is 2 by 2 square matrix. Matrix B is what dimension? 1, 2. This is a 2 by 3 square matrix. So the number of columns of matrix A is 2. Number of rows of matrix B is 2. So the number of columns of A and number of rows of B matches. Hence, matrix multiplication can be performed. And if we multiply now a 2 by 2 matrix by a 2 by 3 matrix, what dimension do we get? We get a 2 by 3 matrix. So if we perform A times B, what we expect to get at the end should be a 2 by 3 matrix. So I want to find A times B, which I'll just write as AB. Okay, we shall write as AB. So this is equal to, so I write matrix A out. Matrix A is 2, 4, 3, and negative 2. Now I'll leave a space here and write matrix B here. And you see why I'm doing that later. 3, 0, negative 5, 4, negative 3, and 7. Matrix multiplication is performed carefully. Otherwise, you make mistakes. Okay, so I'm going to write down here so that I get enough space for myself. Now, how we perform this matrix multiplication is this. We're going to use the first row of the first matrix A and multiply through each column of matrix B while taking the sum. You know what I mean? Now, the first row of matrix A has the entries 2 and 4. How I like to do it is, in my mind, I'll write 2 here and 4 here. 2 and 4. That's the first row of matrix A. So I take the first row of matrix A and put it here like a column. In between matrix A and B, I put it in this manner. It makes me understand better. Now with this, I can perform. So I'll first use, this man to multiply. I'll use 2 and 4 to multiply row 1, to multiply column 1 of matrix A. I use 2 and 4 again to multiply column 2 of matrix B. Rather, I use 2 and 4 again to multiply column 3 of matrix B while taking the sum. So we start. 2 times 3. I'll use brackets. 2. I'll just use dot here for times. 2 times 3 plus 4 times 4 plus 4 times 4. Now I'm done with the first column. I'll now move to the second spot, to the second column. 2 times 0, 2 times 0 plus 4 times minus 3, 4 times minus 3. The third column will now be 2 times minus 5, 2 times minus 5 plus 4 times 7 plus 4 times 7. I have used the first row of matrix A and multiplied every column of matrix B. So the first one is 2, 4, I put it here. 2 times 3 is here, plus 4 times 4. And I move to the next column. That's the next column here too. 2 times 0 plus 4 times negative 3. The next column, I move 2 times minus 5 times 4 times plus 4 times 7. I come over here. Now I have exhausted the multiplication of every column of matrix B. So I am done using the first row of matrix A also. So what I want to do in my head is to now take out this first row of matrix A and bring in the second row of matrix A. Second row of matrix A is 3 and negative what? And negative 2. I'll repeat the same process, but now I'll come down to the second row also of my new matrix. Now I have 3 times 3. I come down. So now 3 times 3 plus minus 2 times 4. Minus 2 times 4. I'm done with the first column of matrix B. And I move to the second column. 3 times 0. 3 times 0 plus negative 2 times negative 3. Negative 2 times negative 3. I'm done with the second column. Now in the third column. 3 times negative 5. 3 times negative 5 plus negative 2 times 7. Negative 2 times 7. Now, I've exhausted all the rows of matrix A. So multiplication now is complete. The next thing I want to do is to now tidy up what I have here, and that will be the result. So we tidy up. So 2 times 3 is 6. 4 times 4 is 16. So that is 6 plus 16. 2 times 0 is 0. 4 times minus 3 is minus 12. So that is 0 minus 12. 2 times minus 5 is minus 10. 4 times 7 is 28. So that is minus 10 plus 28. 3 times 3 is 9. Minus 2 times 4 is minus 8. 3 times 0 is 0. Minus 2 times minus 3 is plus 6. 3 times minus 5 is minus 15. Minus 2 times 7 is minus what? 14. So what do we get? This gives us 6 plus 16 is 22. 0 minus 12 is minus 12. Minus 10 plus 28 is 18. 9 minus 8 is 1. 0 plus 6 is 6. Negative 15, negative 14 is minus 29. And that is our matrix AB. A times B. So what do we see? What dimension is this matrix? This is a 2 by 3 matrix. Does it correspond to what we expected? Yes. A was a 2 by 2 matrix. B was a 2 by 3 matrix. And we had expected that if a 2 by 2 matrix is multiplied by a 2 by 3 matrix, we should get a 2 by 3 matrix. So 1, 2, 1, 2, 3. AB is a 2 by 3 matrix. So we want to perform now BA and see if BA will be the same as AB. So for BA, we'll now we'll put down matrix B first. So 3, 0, negative 5, 4, negative 3, and 7. Then we'll leave our space again, a little space. You know why now? And put in matrix A. Matrix A is 2, 4, 3, and negative 2. Of course, we must check first if multiplication is possible. Let's check. Matrix A, matrix B here has what? 1, 2, is a 2 by 3 matrix, 2 rows and 3 columns. Matrix A is a 2 by 2 matrix, 2 by 2 matrix. So what happens? Let's see. Matrix B has 3 columns, while matrix A has 2 rows. Whoops, the number of columns of matrix B and the number of rows of matrix A do not correspond. So what happens? ABA is not possible. So we cannot multiply matrix B by matrix A. So what have you seen here? You've seen that now. Clearly, it was possible in the first instance, to multiply matrix A and B. AB was possible, but now BA is not possible. So what happens is, so what does it tell us? So we leave the following remark. That as long as matrix multiplication is concerned, that AB is not always equal to what? BA. So we're saying that matrix multiplication is not always commutative. The term for this is what we call commutativity. So this tells us that matrix multiplication is not commutative. In fact, in this case, you see that BA is not even possible. There are instances where BA is possible, AB also possible, and AB will be different from BA. In fact, our next example should be able to illustrate, that sense to us. So let's take this example. A is a 2 by 2 matrix with the entries 1, -1, 2, 3. B with the entries 3, 2, 0, and 1. They are both 2 by 2 matrices. So we want to find AB and also BA. So let's see what happens. So I want to find AB. So AB means you write A first, 1, -1, 2, and 3. I keep a little space and write matrix B, 3, 2, 0, 1. Of course, we have to check if it's possible. So matrix A is a 2 by 2 square matrix. Matrix B is also a 2 by 2 square matrix. So what happens? The inner dimensions here correspond, right? Yes. So matrix multiplication is possible. So if we multiply 2 by 2 by 2 by 2, what do we get? We should get a 2 by 2 matrix, right? Good. So let us go on with the multiplication. You know what to do by now. So this is equal to, I write out. So you know what? So what do? We use the first row of matrix A, which is 1 and -1, to multiply every column of matrix B. So the first row of our first matrix is, we put it here, 1 and -1. Then multiply. So now 1 times 3, so 1 times 3 plus -1 times 0, -1 times 0. Move to the next column. The next column, so we also move 1 times 2, 1 times 2 plus -1 times 1, -1 times 1. We are done with the first row now, since we have exhausted the columns. So we'll now take out the first row and bring in the second row. Second row of matrix A is 2, 3. So I'll now put 2, 3 here. So 2 and 3. Now 2 times 3, I move also to the second row. 2 times 3, 2 times 3 plus 3 times 0 plus 3 times 0. I'm done with that column. And I'll move to the second column. 2 times 2 plus 3 times 1. 3 times 1. So I'm done. Since I've exhausted all the rows of matrix A, so I am done. And I'll take down my answer. So 1 times 3 is 3. -1 times 0 is 0. So 3 plus 0. 1 times 2 is 2. -1 times 1 is -1. 2 times 3 is 6. 3 times 0 is 0. So 6 plus 0. 2 times 2 is 4. 3 times 1 is 3. So that gives us 3 plus 0, 3. 2 minus 1, 1. 6 plus 0, 6. 4 plus 3, 7. So that is AB. So in this case, in this example, we can also perform BA, since they are both 2 by 2 matrices. So B is 3, 2, 0, 1. We leave a small space and write matrix A, 1, -2, 2, and 3. So let's multiply. So the first row of matrix A is 3, 2. All right, 3 and 2 here. So what do I get? I'll get 3 times 1, so that is 3 times 1, plus 2 times 4, 2 times 4. And I'll move to the second column of matrix B, or matrix A now. So 3 times -1, 3 times -1, plus 2 times 3, plus 2 times 3. I'm done with that column. So I now take out these entries here and now bring in the second row. So second row is 0, 1. I place 0 and 1 here. I repeat the same process. So 0 times 1, 0 times 1 plus 1 times 2, 1 times 2. Second column, 0 times minus 1, 0 times minus 1 plus 1 times 3, 1 times 3. And I'll tidy up what I have, and that will be 3 times 1 is 3, 2 times 4 is 8, so 3 plus 8. 3 times minus 1 is minus 3, 2 times 3 is 6, so plus 6. 0 times 1 is 0, 1 times 2 is 2, so plus 2. 0 times minus 1 is 0, 1 times 3 is 3, plus 3. So what do we get? 3 plus 8 is 11, minus 3 plus 6 is 3, 0 plus 2 is 2, 0 plus 3 is 3, and that is what BA. So what do we observe? We observe again that AB is different from BA. So if you're asked to compute AB, do not make the mistake of computing BA thinking that matrix multiplication is commutative. They are not. Of course, there are other properties of matrices which we shall consider in a much later video. Now we are given two matrices of higher dimension, so we want to compute AB. But first, let's check if it's possible. So matrix A is of dimension 1, 2, 3, 1, 2, 3, 4. There are 3 rows and 4 columns. So this matrix is a 3 by 4 matrix. Matrix B is a 1, 2, 3, 4, 4 rows by 1, 2 by 2 columns. Matrix B is a 4 by 2 column. So question is, can we compute AB? Can we multiply matrix A by matrix B? Answer is yes, because the number of columns of matrix A corresponds to the number of rows of matrix B, the inner dimensions here. They match. So matrix multiplication is possible. Now when we multiply 3 by 4 by 4 by 2, what do we expect to get? We expect to get what? A 3 by 2 matrix. Okay, so let us go on now to multiply. So here we have bigger matrices, so you see that it can also be done for bigger ones. So AB is equal to, we place matrix A first, 2 minus 2, 0, minus 1, 4 and 1, 0, 2 and 3, 1, 1 and negative 2. As usual, we leave a little space and write 1 minus 2, 1 and 0, 2, 1, 3 and 1. And now we are ready. Are you ready? Yes. Like we did before, our small trick, we use the first row of matrix A and multiply the 2 columns of matrix B. Use the second row of matrix A, repeat the process, use the third row of matrix A and do the same. If matrix A had more rows, we'll keep repeating it till we get to the last row. So what's the first row? First row is 2, I'll write there 2, negative 1, 0 and 1. That's how I'll do it. It helps me understand. So I now proceed. So 2 times 1 will now be 2 times 1 plus minus 1 times minus 2 minus 1 times minus 2 plus 0 times 1, 0 times 1 plus 1 times 0, 1 times 0. I've exhausted all the terms, all the entries in the first column of matrix B. And now move to the second column of matrix B. So 2 times 2, 2 times 2 here. So 2 times 2 plus minus 1 times 1, minus 1 times 1 plus 0 times 3, 0 times 3. The last one plus 1 times 1, 1 times 1. So I'm done with the first row of matrix A. So I now take off the entries of that row and bring in the rows. I'm bringing the second row of matrix A. So second row, we have minus 2, we have 4, we have 2, and we have 1. So I'll repeat. So minus 2 times 1 will give us minus 2 times 1 plus 4 times minus 2, 4 times minus 2 plus 2 times 1, 2 times 1 plus finally 1 times 0, 1 times 0. We now move to the second column of matrix B. So minus 2 times 2, minus 2 times 2, plus 4 times 1, 4 times 1, plus 2 times 3, 2 times 3, plus 1 times 1, 1 times 1. We've exhausted now the multiplication of the second row. So we'll now take the second row entries away and bring in the third row entries. So the third row is 0, 1, 3, and 2. So 0, 1, 3, and negative what? 2. That is the third row. And then multiply again. So I will now have, so 0 times 1, so that is 0 times 1, plus 1 times minus 2, 1 times minus 2, plus 3 times 1, 3 times 1, plus minus 2 times 0, minus 2 times 0. And I move to the second column. 0 times 2, 0 times 2, plus 1 times 1, 1 times 1, plus 3 times 3, 3 times 3, plus negative 2 times 1, negative 2 times 1. Good. Are we true? Yes, we are true. How do you know we are true? We are true because we have exhausted all the rows of matrix A. Very good. So now tidy up what we have and see that we have one sweet thing. Let's see. So 2 times 1 is 2. Minus 1 times minus 2 is what? Is 2. So that is plus 2. 0 times 1 is 0 plus 0. 1 times 0 is 0 plus 0. 2 times 2 is 4. Minus 1 times 1 is minus 1. 0 times 3 is plus 0. 1 times 1 is plus 1. Okay? Minus 2 times 1 is minus 2. 4 times minus 2 is minus 8. 2 times 1 is plus 2. 1 times 0 is 0. Minus 2 times 2 is minus 4. 4 times 1 is plus 4. 2 times 3 is plus 6. 1 times 1 is plus 1. Beautiful. 0 times 1 is 0. 1 times minus 2 is minus 2. 3 times 1 is 3. Minus 1 times 0 is, minus 2 times 0 rather, is 0. 0 times 2 is 0. 1 times 1 is 1, 2 plus 1. 3 times 3 is plus 9. Minus 2 times 1 is minus 2. Sweet. We now tidy up and get our last matrix. So 2 plus 2, 4. 4 plus 0, 4 plus 0, 4 again. So we have here 4. 4 minus 1, 3. 3 plus 0, 3. 3 plus 1, 4. Minus 2 minus 8 minus 10. Minus 10 plus 2 minus 8. Minus 4 plus 4, 0. Plus 6, 6 plus 1, 7. 0 minus 2 minus 2. Minus 2 plus 3, 1. 1 plus 0, 1. 0 plus 1, 1. 1 plus 9, 10. 10 minus 2, 8. Now what is this? This is what? 1, 2, 3. This is a 3 by 2 matrix. Is that what we're expecting? Let us check. We said here that a 3 by 4 matrix times a 4 by 2 matrix should give us a 3 by 2 matrix. And here it is. I guess with these examples, you are able to understand now how to perform matrix multiplication. Please leave a comment on the comment section, like, and also subscribe to this channel. Thank you, and bye-bye for now.